And with HTTP 1, the browser was limited in the number of connections it was opening, and loading a lot of JavaScript files resulted in waterfalls, and that resulted in many round trips to get the resources down to the user. We thought that HTTP 2 will fix everything, but reality proved to be more complex than that. It fixed some of it to some extent. The cost on the network for each request is significantly reduced, but that doesn't mean requests are now free. Each resource is still compressed separately. So even with H2, if you don't bundle your code, compression rates are significantly smaller. And that is because compression algorithms rely heavily on backward references, and smaller files have less backward references to refer to. We tried to tackle that in the past with a proposal to enable cross-stream compression for HTTP. That never took off, mostly because security concerns about the risk of mixing compression and encryption, and so that didn't work out. On top of that, there's a lot of internal processing resulting in extra cost per request. The requests are created in the render, then being sent to the browser process, which then sends them to the network service, which then potentially check for them in the HTTP cache. And all that has a cost, and service workers also add a few hops to that equation. So that works fine if you have a small number of requests, but if you have hundreds or thousands of tiny modules, which is what large sites are doing today, that can result in a substantial slowdown if we send all of them like as separate resources. And that's in the order of 1 millisecond per request, roughly. It varies, it's not linear, but as a result, people bundle their code using Webpack, Rollup, and other bundlers. Those bundlers do a bunch of optimizations beyond just bundling all the scripts into a single file. They do code splitting to make sure routes have separate bundles, various hashing related, like they hash the URLs in order to make sure that URLs have content-based hashes, which enable long-term caching. They do all kinds of optimization and transformations like image compression, text compression, minification, etc. So bundlers today have multiple output format options, but all of them boil down to essentially a big ball of JavaScript. All of them is a single JavaScript file, resulting in loss of any caching ability of the separate resources. And losing caching is not great because files change, and if small parts of your JavaScript blob change, that means you have to invalidate it and re-download the entire bundle. Also, modules can be shared across different entry points to websites, and there's no way to do that if you send all your script in a big blob. There's no shared module paradigm there. Like there are some bundlers and some sites try to have a separate bundle for the shared stuff, but yeah, if you have an entry point, you end up having many different definitions of what's shared between those entry points. And essentially, we have a granularity trade-off here. That means that there's inherent trade-off between bundling, which is great for delivery, and caching, which is great for not having to deliver anything. And folks who bundle their scripts, or the bundlers themselves, need to think long and hard about each, like which modules or which chunks they can include in each bundle to minimize the risk of cache invalidation and maximize sharing, and that's not a feasible trade-off. So Another issue with the big ball of JavaScript approach is that execution cannot start before we've downloaded and parsed the entire file. And when the network is constrained, that can add a significant delay to the time we can start running any chunk or any module in that file compared to if we had streamed execution. That means that the browser is forced to execute the entire bundle on the main thread only once it arrives fully, which can result in long execution tasks in order to initialize everything that the bundle initializes. If we look at this module structure as an example, we can see a simple dependency tree, and below is the order in which it would be executed. With streamed parsing today in V8, the cycle of downloading and parsing of the scripts is actually being parallelized. That's not necessarily true for all browsers, but we're lucky with V8, and this works for us. We could theoretically also improve things further by optimizing the engine to enable parallel compilation of inner functions, and that could bump things forward and make sure that make sure that compilation is also done roughly in parallel to the download and parse phases. But that still leaves out execution, and execution cannot be parallelized in JavaScript. But if we had a magical way to enable efficient download of the entire bundle with the compression and compression benefits while maintaining file-by-file granularity, we could reach something like that, which is very close to execution in parallel to all the other phases. So engines with streamed parsing would still do the parsing and potentially the compilation in parallel, but they can start execution right after the first chunk or the first module has finished compiling. And that would also hugely benefit other engines that don't have those optimizations. So WebBundles to the rescue. That's how I see that magical format being realized. To be clear, WebBundles is a feature Jeffrey Yaskin is working on. Say hi, Jeffrey. I'm merely proposing new uses for the work that he's been doing already. So what's WebBundles? It's a new format that enables us to wrap a bunch of HTTP requests and responses into a single file. Think MHTML, but without the suckiness of multipart. So while WebBundles can be used for any kind of resources for JavaScript, because of what I just described, I think they can be a great fit and make everything faster. Because having a single resource that contains separate individually addressed sub-resources can help us resolve that granularity problem I just described and eliminate all the trade-offs that developers have to struggle with. When it comes to compression, a web bundle is a single file and can be compressed as such with the backward references that refer from one resource to the previous one. When we talked about cross-stream H2 compression, there were a bunch of security questions that were raised, but they don't really apply here because the compression for web bundles happens on a static file as part of the build process. So it doesn't include any per user data. And as such, there is no way to exploit the bundle compression to extract such data from one resource to the other. So web bundles will give us the same compression benefits that we see from Webpack today compared to the unbundled approach. When it comes to caching, we'll see major improvements because we'll be able to share individual resources between different bundles and different entry points. With the big ball of JavaScript approach, we're losing individual files and we're losing granularity. In the WebBundle approach, each file maintains their own URL and their own caching headers, and resources inside the bundle can have different lifetimes than the bundle itself, lower lifetimes, and the content referencing the resources inside a bundle can modify itself to not reference one of them while referencing all the rest that are already in cache. So a single invalidated resource doesn't invalidate the whole bundle. How can we use this, or what's the plan? This is one proposed way to declare sub-resource bundles as a separate link tag that declares the bundle, and then the resources inside the bundle are referred to using their regular URL. A couple of questions that follow from that are, how can we avoid double downloads? How can the browser know which resources are in the bundle before it downloaded the bundle? And the second question is, how can we communicate cache state to the server to avoid re-downloading bits of the bundle that are already in cache? So as an aside, H2 server push had a slightly similar problem where folks were using it to push resources already in the cache, wasting bandwidth and the user's time in the process. That's something I worked on a bit for the H2 push case by sending the server a digest, which is a probabilistic data set representing all the URLs that are in the cache for that particular origin. Eventually, H2 push implementers were not excited about implementing this, but one way to solve those two problems is a scope attribute that will reuse the cache digest concept and enable the browser to match any outgoing requests that fall in the scope of the bundle to the bundle and avoid double fetching those resources, and at the same time reuse scope-based cache digests to notify the server which resources are part of that bundle or in that scope and are already in cache. So in this scenario, the browser will keep track of all its cached resources that are included in the scope and send a digest. The problem with that is that this is likely to have significant implementation costs because this is not the way that caches are currently arranged. And currently, the HTTP cache doesn't enable a way to generate digests on the cached resources or cached URLs based on arbitrary scopes. So this is something to take into consideration. Another proposed alternative, or a complementary proposal, perhaps, is a resources list, where we have a resources attribute which outlines all the resources that the bundle contains. That enables us to be significantly more efficient and send either hashes or a bitmap of the resources in the bundle and indicating their cache state. That would be significantly simpler to implement with current cache implementations. At the same time, it puts some overhead on the developer where they have to generate those resources lists, maintain them, and they're likely to clutter the HTML. So probably part of the build toolchain, but now the build toolchain has to include HTML as well. That adds some complexity. So what I have in mind is to have the full bundle generated at build time in a similar way to how bundles are generated in Webpack and Rollup today, but outputting WebBundles instead of a JavaScript blob. And then have a dynamic server component that can take that bundle, take the request that the browser sent for the bundle, and use the information from the request and from the bundle in order to subset the bundle and exclude any resources that the browser already has in its cache. That server can be stateless because it doesn't need any information other than the bundle itself and the request with the digest or a bitmap. In terms of compression, one potential glitch in the plan is that for static files, for completely static files, we get highly efficient Brotli compression levels during build time by using Brotli 11, which they take a lot of CPU time to compute, but they can produce files that are 10 to 15% smaller. And that creates another trade-off between subsetting the bundles and sending highly compressed original, like the highly compressed original fuller bundles. But I was fortunate to host an intern this summer that took a crack at this problem and managed to reuse the information that the compressor generates while creating the Brotli 11 compression and reuse that on a subsetted version of that same bundle. So in other words, we can reuse compression information from the entire bundle and use it to recompress the subsetted one to gain significant benefits as well as compression time benefits. So we got up to 5.3% smaller files for the subset compared to on-the-fly Brotli 5 compression with faster compression speeds. And that means that we can get both on-the-fly compression and high quality when operating on bundle subsets. And finally, when it comes to execution with a web bundle, we can get the file-by-file granularity we talked about before and get to almost streaming execution without any fancy JavaScript engine optimizations, which can help a bit to like on the left-hand side, but don't impact the overall parallelization, just because we're dealing with smaller individual files. Okay, so does this require ES modules? Not really. The scheme here is something that can be useful for any content that is composed of multiple small resources. So theoretically, that can be also useful to replace image sprites, which I recently discovered are still a thing, at least when loading like hundreds of them. In particular, that can be useful to deliver classical scripts and doesn't need to rely on ES module dependency trees. At the same time, I think this scheme is required to enable fast ES module loading and competitive ES module loading compared to classical scripts. I think that, yeah, at the same time, ES modules will also need some semantical changes in order to make that happen. So we'll need to be able to deliver the dependency tree along with the first module in order for it to start executing. We need to allow eager execution before the full module tree is downloaded. Right now, if anywhere in the dependency tree there's an error, we need to abort before starting to execute anything, and we'll need to change that semantic, potentially with an opt-in. And finally, we'll need the ability to run tasks between modules because modules can be executing with a long gap between one another because they're still downloading from the network. So to sum it up, JavaScript loading is suboptimal. Bundlers are doing what they can, but we need to support that whole ecosystem better. Web bundles can significantly improve caching, resource sharing, and execution speeds without compromising on compression quality, which yeah, wins all around. And if we want fast ES module delivery, we'll need that plus some more work to make that happen. But bundles are a great start. And with that, let's talk.
I had a question.
What do you all think?
I had a question in the chat about whether there are good examples of sites polyfilling the feature in the past with their own proprietary stuff.
Polyfilling web bundles?
Or just like putting everything into a big file and then use differential downloads and stuff to simulate all these benefits you're talking about.
I am not aware of that. Yeah, theoretically, you could do that with a service worker that downloads a single file and then splits some sort of a bundle format into smaller individual files. I'm not aware of that being polyfilled. But yeah, that could be an interesting way to test that, or at least to test some benefits. I suspect that there may be some overheads with that approach that will result in a trade-off.
Don't some large sites have bespoke module systems where they have their own protocols for indicating which ones they want, and some approaches relating to cache?
Yeah, lots of CDN style systems build those out. Like polyfill.io has a similar query string based differential system where they use the understanding of the client, but that's not cache oriented. They don't really know what the cache is. We have seen some folks prototype this for service workers already, which has been interesting, but it's not that's not common.
Yeah, so I know that so there's the construct a bundle on the fly approach that polyfill.io has one. I also like Google bundle serving is also generating bundles based on the URL itself, and that includes all the different chunks. They don't I'm not aware of them trying to break that up then on the client side and feed that to the JavaScript engine separately.
Okay. So I guess do you think the argument that this would be a significant performance win for sites is much more straightforward than for HTTP push, because it's just more explicit and the site owner can design it themselves?
So yes. Plus, I think that one of the cardinal sins of server push is that cache digest wasn't part of the protocol to begin with. And they relied on people doing a bunch of cookie-related shenanigans to get around that, and that didn't work out well.
And they also integrate with the cache. Like if you pushed something, the client had to also request it in order to get it into the cache.
Yeah. Which wasn't defined anywhere. It's just the implementation detail that everyone happened to implement this similarly. So I'm hopeful that that building the differential serving mechanism from the get-go will help us avoid the server push situation. Yeah.
I especially also really agree with your statement about sites won't be able to go all in on ES modules easily without a technology like this. I mean, I guess they could do some a lot of build tooling to hack around it, but it seems like a much cleaner solution to do something like this.
Thanks. Yeah, on a similar note, we have we are talking to a bunch of Dan from Igalia and Yuda Katz from Amber are excited about this, are pushing for this, or playing around with that problem space. And we also had a meeting with a bunch of folks from the bundler community that Dan organized that was very they're very positive about this approach. compared to what they're currently doing. So they feel the current pain, and this will solve their pain.
Cool. Is it like Webpack and stuff? Is that what you mean by bundler community?
Webpack, Rollup, Snowpack, others. Yeah.
That's awesome.
Thanks. Alex, you have your hand raised.
Yeah, you mentioned bundles with regards to use inside of service workers for unpacking. And one of the use cases we had postulated many years ago was the ability to fetch and pre-populate service worker cache storage, sort of programmatic caches. Has thought been given to either easy exploding into a cache or an API for enumeration and extraction of resources?
Not beyond just saying that we need something along those lines, but I agree that we need something along those lines.
Cool, thank you.
Yeah, we haven't designed
it. Would somebody mind repeating Alex's? Broke up a little bit.
Oh, yeah, sure. So basically, have we considered having APIs that will either explode bundles into the cache or be able to query bundles for their various resources? Is that a good representation of your question, Alex? Yeah, okay, yeah. Eddie Nelson, you have your hand raised.
Yes. All right. Hey, hi. So I got two questions. First, I mean, how close to completion is the current proposal? And the second question is, anyone started looking to performance on mobile, specifically on ARM?
So it's a very early proposal. The Tokyo loading folks are playing around with prototypes for web bundles and sub-resource loading. I don't think that we have implemented any of the differential serving mechanisms. But theoretically, you could play around with the prototypes they're working on to measure performance, but I think it's still a work in progress. I don't think we're perfectly happy with the results they're getting, but they're getting, consistently better. So I think that the tests are being run on mobile as well. So so it's definitely a consideration, but I don't know if there's anything ARM, any ARM specific knowledge or any other mobile specific things you would like to see in those tests. It would be great to have you talk to the team and make sure that we're looking at everything we should be looking at.
Cool.
Cool.
I think Dan's hand is raised as well.
Yeah.
Right?
Yeah.
Hi. Yeah, I'm super excited about this and the potential for solving the module's performance issues. One thing that I remember reading about the last time I was reading about this proposal was that there were objections from Brave and maybe others about this potentially making it harder for ad blockers to work. My reading of that was it's not necessarily the case, but I was wondering if where do you feel that debate stands? Do you see that as being a stumbling block that needs to be surmounted, or is this just not well-founded and needs to be pushed back against?
Jeffrey, do you want to take that?
I take that. Dan Ehrenberg has been doing a good job of talking to the Brave folks and the other folks concerned about those issues and kind of figuring out what the underlying concern was. It sounds like limiting bundles to be same origin explicitly and not and kind of reject a bundle with a cross-origin resource inside it is enough, which kind of doesn't match my understanding of their objection, but if it makes the objection go away, great.
That's good to hear.
And then interact with the cache, put pressure on. Sorry, what?
I was just saying it's good to hear.
Oh yeah. Also having the bundles interact with the HTTP cache and have browsers assume that the bundle contains kind of accurate claims about the rest of the server also pushes against any server that wants to misuse bundles. So I think it's not an issue, and I think that Dan has had good progress convincing the Brave folks that at least the subset without any signing is not an issue.
Thank you.
Cool. Any other questions? So given that we're 2 minutes over, yeah.
Yeah, I was just going to ask a super quick question, which is there any thinking about cache partitioning in this in terms of ever trying to have creative schemes to allow a web bundle to somehow share a cache? Like maybe web advertising scenarios. If I get an ad bundle, obviously like with fenced frames, maybe that's the cache partitioning aspect. But if we're advertising what's in the cache, it seems maybe a little harder to perhaps deduplicate things. I was wondering if you had any thoughts on, is there any relationship to this in cache partitioning?
You definitely can't tell one origin about another origin's cache contents. And so I think we've been assuming that kind of as the HTTP cache is partitioned, like bundles get partitioned along with that. There is some thought about how to use bundles to improve unsigned ones with a sub-origin concept and signed ones, which kind of feed into the privacy sandbox proposals in complicated ways. This is probably not the time to get into all the details there, but yeah, we think that bundles in general can help with some advertising cases also.
Thanks.
Cool. So yeah, thanks all. And yeah, feel free to bug me with questions afterwards, and let's continue the conversation.